Mathematics, the term we use almost every day and the universal language of truth. This fascinating subject that we are aware of has many branches, the most notable being arithmetic, set theory, statistics, geometry, algebra, probability, trigonometry, and calculus. There are many more which have been laid by a lot of people in a very interesting history regarded as the history of mathematics. Its history is divided into many groups according to the time period and other factors. Prehistoric mathematics. It is unknown when mathematics truly started leaping. However, we can analyze that our ancestors started basic counting during the prehistoric era about a few millennials BC. They first started counting when people hunted for animals. People didn't really need a lot of numbers as they would only have to hunt for up to 2 animals per day. This is why they had defined 1 and 2 but not others. Instead, they defined it as many. People kept records of occurrences such as days, nights, seasons, phases of the moon using tally marks and daily objects, which set the foundation of mathematics by counting. This can be found in notched bones from Africa dating 20,000 years or so. Stonehenge, a popular monument in England and a quite popular tourist spot, dates back 2300 BC and is an example of the sexagesimal measurement system with base 60. The stone exhibits regular intervals of patterns formed by the base 60 counting principles. Sumerian and Babylonian mathematics. Sumer, a region of Mesopotamia, was one of the earliest civilizations to exist. They are credited to create the earliest form of writing system. They used pictures to represent numbers which were inscribed in baked clay tablets. They further carried out sexagesimal system which influenced today's hours, minutes, and second system of calculating time. With this civilization, there came many bureaucratic needs after the civilization massively developed in agriculture. They needed to calculate area to buy and sell lands. They invented proper numbers for tax calculation and basic arithmetic. They used their observation of the sky patterns, weather patterns, and day and night patterns to put together the first yet sophisticated calendar. They further developed geometrical concepts using their base 60 of counting. They invented place values and arithmetics. They established a degree system to calculate the angles of any geometrical shape. They also showed hints of the first multiplication and division. They also invented the number 0, which led to a lot of possibilities in the centuries to follow. Linear equations were given around 1800 BC in Babylonian civilization. There came the concept of pi, which was estimated to be 3.12 at the time. Egyptian mathematics. The Egyptians settled in the fertile banks of Nile at about 6000 BC and started recording lunar patterns for bureaucratic, agricultural, and religious reasons. They started concept of mensuration with the help of their hands, legs, and arms. Though this was not reliable, this solved their needs. From then onwards, the decimal number system with base 10 was developed based on counting with 10 fingers. The oldest mathematical text that was found from ancient Egypt is the Moscow Papyrus, which dates from the Egyptian Middle Kingdom around 2000 to 1800 BCE. It is thought that the Egyptians introduced the earliest fully developed base 10 numeration system at least around 2700 BCE. Written numbers used a stroke for units, a heel bone for tens, and a coil of rope for other symbols. They also used hieroglyphic symbols for higher powers of 10 up to a million. The Rhind Papyrus from 1650 BCE is a kind of instruction manual in arithmetic and geometry. It gives us explicit demonstrations of how multiplication and division was carried out at that time. It also contains evidence of the unit fractions, composite and prime numbers, and how to solve the first order linear equations as well as the arithmetic and geometrical series. The pyramids themselves are another indication of the sophistication of Egyptian mathematics. Setting aside claims that the pyramids are first known structures to observe the golden ratio of 1 over 1.618, there is certainly evidence that they knew the formula for the volume of the pyramid. Greek mathematics. The Greek civilization was very notable for the development of mathematics. It began with the ancient Greek numerical called the Attic numerals. It was also a base 10 system like the ones the Egyptians had discovered. They could do addition, subtraction, and multiplication by successive addition. Thales, one of the 7 sages of ancient Greek of the 6th century BCE, is usually considered to have been the first to lay down guidelines for the abstract development of geometry. Thales established the Thales theorem, whereby if a triangle is drawn within a circle with the long side as the diameter of the circle, then the opposite angle will always be a right angle. He is also credited with another theorem, the intercept theorem, regarding parallel and intersecting lines. 3 geometrical problems in particular, often referred as the 3 classical problems, date back to the early days of Greek geometry: the squaring of the circle, the doubling of the cube, and the trisection of an angle. The search for the solutions helped us discover many laws. The Greeks made the first idea of infinity, which led to the very complex mathematic rules being laid down. This was first seen by the Zeno's paradox of infinitive fraction adding. In his paradox, he had Achilles and the tortoise in a race. The tortoise had a head start, and by the time Achilles covered the distance, the tortoise was forward. This repeated, which could be represented by this formula. Pythagoras is another famous mathematician of the Greek civilization. He set the principles of coordinate geometry by widely spreading the Pythagorean triples and the Pythagoras theorem, which in modern mathematics is used very often to derive complex formulae. However, Plato completed his incomplete ideas about irrational and rational magnitudes, which is really important in the history of mathematics. Hellenistic mathematics. By 3rd century BCE, the Hellenes started to discover a lot of laws, greatly due to the wake of conquest of Alexander the Great. In particular, Alexandria in Egypt became a great learning center under the beneficent rule of the Ptolemies, and its famous library soon gained a reputation to rival that of the Athenian Academy. The patrons of the library were the first professional scientists. The most famous people who studied and taught at Alexandria were Euclid, Archimedes, Heron, Menelaus, and Diophantus. During that time, Euclid became a very influential mathematician. He invented Euclidean geometry. Archimedes spent his life in Cilicia and Alexandria, where he became quite a famous engineer and inventor of pure mathematics. A mathematician, astronomer, and geographer, he devised the first system of latitude and longitude and calculated the circumference of the earth. As a mathematician, his greatest legacy is the sieve of Eratosthenes algorithm for identifying prime numbers. It is not known exactly when the great library of Alexandria burned down, but Alexandria remained an important intellectual center for some centuries. In the 1st century BCE, Heron was another great Alexandrian inventor, best known in mathematical circles for Heronian triangles. He was also the first mathematician to confront the square root of -1. Apollonius of Perga was specialized in what is called the conic sections. He derived the geometrical shapes like circles, ellipses, parabola, and hyperbola, which is very important in geometry. Hipparchus from Hellenistic Antilonia lived in the 2nd century BCE, and he was perhaps the greatest of all ancient astronomers. He revived arithmetic techniques first developed by the Babylonians and is usually credited with the beginnings of trigonometry. He calculated the distance of the moon from the earth by measuring the different parts of the moon visible at different locations and calculating the distance using properties of triangles. Roman mathematics. The Roman civilization, which flourished a long time back, made very little contribution to the history of mathematics. However, the little contributions they made were very huge. Roman numerals are very well known today and were the first dominant number system for trade and administration in most of Europe for the best part of a millennium. It was a decimal system but not directly positional and did not include a zero. Thus, for arithmetic and mathematical purposes, it was a clumsy and inefficient system. It was based on the letters of the Roman alphabet: I, V, X, L, C, D, and M. Calculations were usually done in an abacus, which was created by the Babylonians and the Greeks. Mayan mathematics. The Mayan civilization had settled in the region of Central America from about 2000 BCE. At its peak, it was one of the most densely populated and culturally dynamic societies in the world. The importance of astronomy and calendar calculations in Mayan society required mathematics, and the Maya constructed quite early a sophisticated number system. It was the vigesimal number system based on the base 20, originally developed from counting on fingers and toes. The pre-classic Maya and their neighbors had independently developed the concept of zero by 36 BCE, and there is evidence of their working with sums up to the hundreds of millions. Despite not possessing the concept of fraction, they produced extremely accurate astronomical observations using sticks, and they were able to measure the length of the solar year to a very accurate value, which was 365.242 days, as well as the length of the lunar month, which was 29.5308 days. However, due to the geographical disconnect, Mayan and Mesoamerican mathematics had absolutely no influence on Old World numbering systems and mathematics. Chinese mathematics. The trades established by China gave many contributions in the field of mathematics, indirectly as well as directly. The simple Chinese numbering system, which dates back to the 2nd millennium BCE, used small bamboo rods arranged to represent the numbers 1 to 9, which were then placed in columns representing other values. It was therefore a decimal place value system very similar to the one we use today. The Chinese were fascinated with numbers. Magic squares, which were ancient Sudoku puzzles, were regarded as having great spiritual as well as religious significance. But soon bigger magic squares were being constructed with even greater magical and mathematical powers. The main thrust of Chinese mathematics developed in response to the empire's growing need for mathematically competent administrators. A textbook called Jianzhong Shanzhu, or 9 chapters on the mathematical art, became an important tool in the education in such a civil service, covering hundreds of problems in practical areas such as trade, taxation, engineering, and payment of wages. Liu Hui was one of the first mathematicians known to leave roots unevaluated, giving more exact results instead of approximations. By an approximation using a regular polygon with 192 sides, he also formulated a calculation of pi as 3.14159, as well as developing a very early form of integral and differential calculus. Indian mathematics. The Indians started their mathematical discoveries by their Vedic principles. Mantras from the early Vedic period invoke powers of 10 from 100 to a trillion and provide evidence of the use of arithmetic operations such as addition, subtraction, multiplication, fractions, squares, cubes, and roots. In the 8th century BCE, the Indians created the Pythagorean triples on their Sulba Sutras. They also calculated an accurate value of the square root of 2 as 1.41421. As early as the 2nd century BCE, Jain mathematicians recognized 5 different types of infinites. Infinite in one direction, 2 directions, and area infinite everywhere, and perpetually infinite. They developed a lot of concepts regarding zero. They used the first circle character to represent zero and gave birth to this number properly through the Hindu-Arabic numeral system. They proved infinity as the reciprocal of zero, and the Indians also developed quite far in quadratic and cubic equations. The Kerala school of astronomy and mathematics was found in the late 14th century by Madhava of Sangramagravasa. He developed infinite series approximations for a range of trigonometric functions, including pi and sine. Some of his contributions to geometry and algebra and his early forms of differentiation and integration for simple functions that were transmitted to Europe. Medieval European mathematics. By the 12th century, through Italy, Europe was beginning to trade with the East, and Eastern knowledge gradually began to spread there. Robert of Chester translated Al-Khwarizmi's important book on algebra into Latin in the 12th century, and the complete text of Euclid's Elements was translated in various versions by Abelard of Bath, Hermann of Carinthia, and Gerard of Cremona. The expansion of trade and commerce created a growing need for mathematics and arithmetics entered much more into the lives of common people and was no longer limited to the academic realm. By the mid-15th century, important books on arithmetic were also being written, and mathematics was considered important in terms of academics. Leonardo of Pisa wrote the Fibonacci sequence of numbers, which is regarded as very important. The German scholar Regiomontanus contributed a lot of stuff in trigonometry. He helped separate trigonometry from astronomy, and it was largely through his efforts that trigonometry came to be considered an independent branch of mathematics. His book De Triangulis is now taught in high school and college and was the first great book on trigonometry to appear in print. Mathematics in the Renaissance. During the 16th and early 17th century, the equals, multiplication, division, root, decimal, and inequality symbols were gradually introduced and standardized. The use of fractions, decimals also increased. People grew keener in mathematics and created various puzzles and unsolved series. Niccolo Tartaglia revealed to the world the formula for solving cubic equations for the first time. In brief, algebra and arithmetic was greatly developed during the Renaissance. 17th and 18th century mathematics. Many scientists, including Galileo, observed the planet's movement patterns, which helped Kepler's calculations get simplified. It allowed him to formulate mathematical rules regarding planetary motion. Analytical geometry was developed by René Descartes too. It allowed Earth's orbit to be plotted on a Cartesian coordinate graph altogether. Building on earlier works by many predecessors, Isaac Newton discovered the laws of physics, explaining Kepler's laws, and brought together the concepts known as calculus. Independently, Gottfried Wilhelm Leibniz, one of the most important mathematicians today, developed calculus and much of the calculus notation still in use today. Leonhard Euler's contributions range from founding the study of graph theory to standardizing modern mathematical terms and notations. For example, he named the square root of -1 I, and he popularized the use of the Greek letter pi to stand for the ratio of a circle's circumference to its diameter. He made numerous contributions to the study of topology, combinatorics, and more, as evidenced by the multitude of theorems and notations named for him. Other important European mathematicians of the 18th century included Joseph Louis, who did pioneer work in number theory, algebra, calculus, and Laplace, who in the age of Napoleon did important work on the foundations of celestial mathematics and mechanics, as well as statistics. Modern mathematics. Modern mathematics started in the 19th century. Carl Friedrich Gauss did revolutionary works in the field of geometry and series. He stated the fundamental theorem of algebra and quadratic reciprocality law. Non-Euclidean geometry and elliptical geometry also developed in the 19th century. The 19th century saw the beginning of abstract algebra. Hermann Grossmann from Germany gave a first version of vector spaces. William Rowan Hamilton in Ireland developed non-commutative algebra. The British mathematician George Boole devised an algebra that evolved into Boolean algebra. Boolean algebra is the starting point of mathematical logic and has important applications in electrical engineering and computer science. On the other hand, the limitations of 3 dimensions in geometry were surpassed in the 19th century through considerations of parameter space and hypercomplex numbers. In the late 19th century, George Cantor developed set theories, which made the study of infinity easier. During 20th century, Ramanujan, an Indian mathematician, exercised a great deal of mathematics regarding sequences. That ended after his unfortunate death at the age of 32. Again, pi's value was refined up to more than 1 trillion accurate digits using computers. Computers changed with the hexadecimal, octal, and binary number systems. Calculus and algebraic geometry was also exercised by many mathematicians. This has led to our present version of mathematics. The information in this video was collected from various sites that are displayed on the screen right now.